All right.
Okay, so welcome to my talk on Aosp, which is an abbreviation for the Android Open Source Project. So the reason I decided to do this presentation is twofold. First of all, as a Java interest group, Android is a very interesting platform for Java developers because the language of application development on the platform is Java. But it turns out it doesn't stop there, that the Java actually goes down quite a bit of a way in the stack. So if you have Java experience, then learning something about how Android is built can be a way to leverage that experience. Secondly, there's lots of presentations and tutorials that are focused on how to build Android applications. And I'm sure some of you have probably at least tried your hand at that. So I wanted to do something a little bit different, so that was the other reason why I decided to focus on the operating system rather than the applications. My name is Wilhelm Fitzpatrick. I have been around the Seattle community for a long time, most of it doing Java. About 4 years ago, I decided to shift my focus over onto Android, being complementary with what I was already doing. And I am currently working for a company called Sienagen Inc, which I will speak more later. So, here's a rough outline of what I want to talk about. Talk a little bit about what Android is, just in case, just to sort of get us on the same page about that, and then what is Aosp. So one of the things I want to point out at the beginning is the goal of this talk is to have a very pragmatic focus. Android and Aosp is a very large topic, and while I will talk a little bit about the architecture of the Android operating system, I don't intend to go into it exhaustively. I will point you to some resources that you can use to learn about that if you're interested. But the focus of this talk is basically about how to get to the point where you can start coding and learning. Because if there are two words that I would use to describe Aosp, it would be big and brittle. There's a lot of code there, and the process of getting it on your machine and actually producing something from it can be very failure prone. So the goal here is to basically give you enough orientation with concepts and procedures that you could get to the point where, should you be interested, you can get Android onto your machine, be building something, and actually seeing it run and experiment with that. So that is the focus of tonight. All right, well, let's see if the network works. Try that again. Try one more reload, and then it will show anyway. Anyway. Huh, all right. Looks fine to me. Okay, so what is Android? Well, I think everybody is pretty aware that it's a mobile operating system, and it's also, at this point, the most widely used mobile operating system in the world. But you can also think about it as the most popular Linux distribution ever, because it's absolutely true that Android is built on top of Linux, although, as I will point out in this presentation, it's a different kind of Linux than most of the other Linuxes out there. The developers of the Android operating system took things very much in their own direction. But the other interesting way to look about it is I remember back when Java first came out, there were all these people who were super excited about the idea of this object-oriented language that was platform independent and could run everywhere. And they were like, we should build an entire operating system in Java. And there were all these little projects that were trying to do that. And even Sun even had their Java OS thing that had a brief life and then sort of vanished into history. But it turned out that we actually got it, because in many ways, Android is that operating system. It is not purely written in Java, but a surprising amount of what makes up an operating system is written in Java and runs in Java on a runtime that can be retargeted at different processors, so that we can have phones that are based on ARM, and we can have phones that are based on X86, and we can have devices that are based on MIPS, and they all run the same operating system. So that's pretty cool. And then finally, it's worth pointing out that that Android is a trademark of Google Inc. The reason I point that out is that we are now going to move toward talking about the Android open source project, and it is an interesting thing that you can. There's all that code. You can take it. You can build something that's an operating system, but unless Google gives you permission, you can't really call that Android. A perfect example of this is Amazon. They have this thing called Fire OS. What is Fire OS? Well, it's basically Amazon's version of Android. But they decided to go their own direction with it, so they had to call it something different. Now, interestingly enough, this little green guy, and the thing that failed to load here was the Creative Commons symbol, turns out not to be a trademark. So you'll see in the world of open source Android, you'll see this little green guy show up a lot, even in places where you couldn't actually say Android. All right, so Aosp is very straightforwardly the Android open source project. It is hosted at this website here. And the idea behind Aosp originally was so back at the dawn of Android, there was this thing called the Open Handset Alliance. And I kind of think of it as like the coalition of the willing, where you've got one big guy who wants to do something, and he bribes a couple other small guys to come along with him so he can pretend that he isn't doing it on his own. So that kind of faded away. But the idea was that, that Google had this mobile operating system, and they were going to leverage this idea that the ecosystems that are open tend to get traction and to win out over ecosystems that are closed. And kind of seems like it might have worked out, but we're gonna look at some of the nuances of that. So what do you find when you go to the Android open source project? What you find is the code for the operating system part of Android. So the thing that I want to emphasize here is if you take this and you build it and you run it, you will have a complete operating system, but you are not going to have the complete end user experience that you would have if you went out and bought a phone running and branded Android. And a lot of that comes down to the presence of Google applications. So is Aosp really open? There is a lot of discussion that goes back and forth in various areas of the tech press of is Android really open? Because Google says it's open, but is that really true? And especially since they are going up against platforms like iOS and Windows Phone, which are definitively closed ecosystems. There is some dispute as to whether this moniker of openness is really justified. So I've broken out a couple points here. So in favor of openness, there is the code for a complete mobile operating system that anybody can take, anybody can fork, It is distributed under the Apache and GPL licenses. The GPL portions mostly are around the Linux kernel, because that's the way Linux comes. The Apache license stuff is pretty much everything else, and that was a deliberate decision on Google's part because they wanted commercial vendors to be able to take that and customize it and not have the obligation to share that code. It is part of the Aosp. You can go and you can make fixes, or if you have an idea for an improvement, you can submit those things. But, and here's where we start to tip to the closed side of things. In the traditional open source project, there's kind of also at least somewhat open management structure that goes along with it. The decision making is done out in the open. But in the case of Android, Google decides what goes in. They have control about where this platform is going. The work on new versions of Android is done in private. Now, as soon as those are announced and go to market, Google so far has been very good about almost immediately turning around and pushing that source out to Aosp so that anybody can look at it. And finally, and this is the point that I was making before, a lot of what we expect our phones to do, having a maps application that can tell us how to get across town, having a calendar application that is reflected in the cloud, having access to cloud email, all these, more and more we're living our lives in the cloud, and our devices are just sort of a window into that cloud existence. So Google has their suite of apps, and these apps are not part of Aosp. Now, what you will find in Aosp in some cases are either older or cut down versions of those applications. So you will find a calendar app in Aosp. It just doesn't happen to be the one that you would get on your certified Android branded phone. So that in that way, the ultimate goal of sort of free and open source, as Richard Stallman once conceived it, was that you had your devices, that you're key to your life. You wanted to be able to control them, make changes to them. So you should be able to either, if you're a coder, make a change, or if you're not a coder, hire someone to make a change, and then put that change onto the device that you own. And because of some of this, that promise might not be delivered 100% through Android, but it's actually pretty close, and there are people out there who are working on making sure that that experience stays as close as possible. So I also mentioned that Android is a Linux. So for those of you out there who are experienced Linux hackers, I just thought I would briefly talk about the ways that the Linux that Android is built on is a little different from the Linux that you might run on your laptop. So the first thing, so the key thing is it's a Linux kernel. It's using Linux device drivers, but the key thing is does not use the Linux standard base. And this is a specification that is adhered to by almost all distributions for how your file system is structured, what command line utilities should be there. It provides a base platform that across Fedora, Ubuntu, CentOS, you name it, that people who are developing for Linux can target this common infrastructure. Android completely goes its own way on that. So in some way, it's kind of like they use the kernel, they use the device drivers, but the user space that we think of as Linux is not there. It also depends on a couple kernel extensions, modifications, I'm not sure what the right name for them would be, that are not part of the main line of Linux. There has been work over time to take some of the things that made the Android kernel unique and bring them into mainstream Linux. Some have come in some cases, the Linux community have come up with alternate mechanisms that are similar to ones that Android used. In some cases, Android chose to adopt them. In other cases, Android chose to keep using their solution because their solution was targeted toward this very specific idea of being a mobile device. So 3 key extensions are Binder, which I'll refer to later. Binder is an IPC mechanism. The Android operating system works by having a number of cooperating services that chat with each other across process boundaries, and this is all achieved through Binder, which has an interesting history. It was originally, if I remember correctly, created by engineers at B, spent some time percolating in the hands of Palm, and then that sort of same pack of engineers wound up as some of the early people working on Android. So they brought along this IPC mechanism that they had evolved and they felt was suitable, called Binder. Ashman is a shared memory device, which is used in concert with Binder to pass large chunks of data efficiently between processes. And then the idea of wake locks, which is very central to a mobile OS which needs to very carefully conserve its power. And this is basically the ability for sections of the operating system to inform the operating system that, hey, you need to keep running in order to service me for a certain period of time, so that, because a mobile device always wants to shut down as much of its CPU as it can and shut down as much of its other hardware as it can. So wake locks are used extensively throughout Android to control that process. Android also chose not to use glibc for 2 reasons. Secondarily, I think they felt that it was, since it was oriented toward desktop operating systems, it was a little big and over-featured for a mobile device, but primarily because glibc is also GPL licensed, and Android wanted as much of, Google, being Android, wanted as much of the Android stack to be Apache licensed as possible. So they wrote their own C library called Bionic. And so for folks that decide to go hacking around in the lower layers of Android, this can be interesting because there's lots of wonderful tools and programs and C code developed in the Linux world on top of glibc that you might want to recompile and run on Android. And this mostly works, but not always, because Bionic makes some different assumptions that glibc does, and more importantly, Bionic is not POSIX compliant. So, whoops, and there goes my slides. So yes, so if you're a Linux hacker and you're looking to hack around on the Linux level of Android, that's definitely something to be aware of. Also, as supplied through Aosp, most of the Linux command line tools aren't there. You'll have stuff like ls and cd, but not a whole lot beyond that. There's a lot of folks out there have solved that problem by taking BusyBox and compiling it to run on top of Android. So there's solutions for that. But ultimately, the big difference is that from the from the kernel level up, Android has this unique user space that is very heavily based on Java, and that is the biggest and most unique thing about it. So, there's been some lawsuits about this. All right, there's definitely a drawback to having all your devices talk to each other. All right, so you know, there's definitely been some lawsuits out there about, is the Java that is Android Java really Java? And you know, for when talking to developers, you know, I think, you know, Google really wants to say, oh yeah, you know, it definitely is Java. It's the Java you're used to. Here's all the cool Java features that you've come to expect. But when talking to lawyers, they say no, it's not. And there is some truth to that, because it really is a very radical reimplementation. It is in no way derived from the Sun Oracle stack that we use in most of our enterprise environments. They took the class library from Apache Harmony, which was a project that briefly existed under the Apache umbrella to take a bunch of work out there on reverse engineering the Java class libraries and pulling in work from a bunch of different sources, and Google wound up inheriting that, and Apache Harmony drifted off into history. So if you know, as someone who is used to working with Java, this Java Standard Edition, you know, you will find most of what you're used to there. The things that you will not find are the Swing AWT GUI layer. Android has its own GUI layer that's very specific to it. And as time has marched on, the version of the Java language that is supported by Android has kind of fallen behind a little bit, if you want to look at it that way. Some of the cool new features that got introduced in later versions of Java haven't quite made it on there. So at the current time, it's kind of a base of Sdk 6 with some features pulled in from Java 7. Basically stuff that the compiler can handle that the runtime doesn't really need to worry about. But certainly, if you're coming, you know, if you are heavily invested in Java 8, for example, coming to Android's Java may feel a little bit primitive. And the runtime, as I mentioned, for most of Android's life, the runtime is something called Dalvik, which was a JVM, well, perhaps not a JVM, a virtual machine that was optimized to run on, yes, it was optimized to run on mobile devices, made some very different decisions. Sort of a curiosity, standard JVMs, the official architecture for them is a stack-based one. Dalvik chose to be register-based. It was originally just an interpreter, but later they added a JIT. But most importantly, it has a bytecode that is completely its own, that is similar to, but not the same as, the Java bytecode. And this bytecode is stored in files that are not Java class files. So when you are building code for Android, it is a two-stage process of using a Java compiler to output class and jar files that are exactly what you're used to, and then running those through a tool that convert them into the Dalvik format. As of Android 5.0, which is known also in the world as Lollipop, Google has introduced a new runtime called ARC, the Android runtime, and it is a bit different from Dalvik in that it is, strictly speaking, not a VM. It is a ahead-of-time compiler, so that bytecode is taken and turned into native executables. But the interesting thing is there's still an interpreter lurking there that these executables can use, because there are actually reasons why, you know, for space or efficiency, that, you know, not all of your code needs to be compiled. You know, if you have some initializers that run at install time and never again, why compile those? It was kind of necessary because Dalvik was built for a time when a mobile phone had much more constrained hardware than our phones do today. 256 meg of RAM, you know, a gig at most of storage. So they set some of their targets maybe a little low for what our phones have turned into. If you look at our phones today, they're kind of where, you know, our desktops were a couple of years ago. So those limitations were starting to show, and so it was time for a new runtime. All right, so why should you be interested in any of this stuff? So some of you may be interested in writing Android applications, but don't really feel like messing around with the operating system. But I think that the fact that the Android open source project is out there actually represents a unique strength of Android, even for application developers, because the best documentation about how all these APIs that you depend on work ultimately is being able to study how they're implemented. And with Android, you can absolutely do this. And while part of my talk is about how you can get the Aosp source onto your own machine and work with it, I'm going to show you also a way that you can take advantage of the existence of Aosp even if you never even install Aosp onto your own personal computer. Okay, but let's say you do. You want to come to terms with this Aosp machine. You actually want to get this code and you want to build something out of it that runs Android, and you want to play around with it. What are you going to need? Well, you're going to need a pretty hefty machine. So these are the requirements that Google outlines on the Aosp site. Is there a question out there? Okay, so yeah, so gotta have at least 16 gigs of RAM just to make it happen. Huge amount of disk space, and if you start doing things where like you want to have a couple different versions of Android available to you, so you can compare between them, or you know, do whatever you need to do, that disk space requirement quickly multiplies. So you have a choice of essentially two operating system environments that you can do this under. The official operating system for building Android is a 64-bit Linux, and specifically at the moment Ubuntu 14.04 is what things are said to, you know, if you're going to go in and follow the instructions, that is the platform where they've been tested and they should actually work. Ubuntu isn't necessarily a requirement because the tools and environment that's being used are available across other Linux distributions, but you may have to figure some things out on your own the further you go from this baseline. However, these days, amazing as it may seem, Macs are super popular for developers, and so building Android is also very well supported on Mac OS X. Getting it set up is a little fussier, and I'm not actually going to address that tonight, but the instructions are out there on Google's site. So folks that make their development home on Windows, unfortunately, unless you build yourself a virtual machine that runs one of these other environments, building Aosp is not something you can do. They're just not choosing to support that. And to build Aosp, in addition to your operating system, you also use Java, and depending on the version you're going to build, it's targeted to either Java 6 or Java 7. So what are the tools you're going to need? The Android open source project is based around Git for version control. Super popular, almost the default version control system now, so I'm assuming most of you here are at least somewhat familiar with that. However, I mentioned earlier that, you know, one of the words that I use to describe Aosp is big. Aosp is more than a single repository. Aosp is actually a huge family of repositories for all the different pieces that make up Android. So in order to manage this big collection of repositories, the folks that worked on Android created a tool that they called repo. And repo is like a meta version control manager. Its job is to take a manifest file or a series of manifest files that describe a collection of Git repositories and pull them down, pull down the correct ones. If you change what branch you're looking at, you can use repo to change that branch across all the repos. Depending on what configuration you're building, you may need some repos or not, some Git repos and not others. Repo is a tool for managing that. Repo also kind of encompasses a set of small accessory tools that all go into actually making the Android build happen. So that's what repo is all about. The Android build system is currently implemented in Make, and I personally am my understanding of Make is very spotty, but based on some reading I've done, my understanding is that the way that the Android developers chose to use Make is very non-traditional. What it basically boils down to is traditional use of Make is kind of if you have like a sort of a tree of modules that you have a top-level Make file that recursively calls down into lower-level Make files. In the Android build system, the top-level Make file actually goes out and reads through all the other Make files and builds this huge dependency tree. As a result, actually, one of the first things you'll notice when building Aosp is that when you type Make, your computer will just basically sit there thinking to itself for about 2 minutes while it's trying to figure out what it should build. There is rumors that Android is in the process of converting over to other build tools other than Make, but for the time being, that's what we have. There is also some Python scattered throughout. There are Python scripts that do various part of the lifting. Because the lower levels of Android are written in C and C++, you're going to need a C compiler, GCC if you're on Linux, Xcode if you're on Mac, and then there's a lot of Java compiling to be done, and that will be done with JDK. And as we go through these slides, all this stuff that I'm telling you, for the most part, can be found in the documentation at Aosp, and pulled out the URLs where this stuff is described in more detail. I'll make the slides available for Nimrit to send around after the talk, so anyone that's interested can come back and look at that stuff. All right, so you've decided you want to do it. What is the process of getting your machine set up? So we're going to assume that we are going with the officially mandated Ubuntu 14.04 distribution. You've installed that on your laptop or you've installed it in a VM. And now what do you need to do? Well, you need to get Java. So here I'm showing OpenJDK. Prior to Android 5, Android recommended the Oracle JDK, but they moved over to OpenJDK. They're kind of interchangeable, but if you were building an older version of Android, there might be some speed bumps. All right, but we're going to build the latest things. We're going to get OpenJDK, and then there are a few development tools and libraries that are not part of what by default gets installed on Ubuntu that you need to pull down. So those are listed here, and it's actually not that big a gap. It's interesting too, if you go and look at the documentation that I mentioned here, they show you the setups for older versions of Ubuntu, and this line here has been getting progressively smaller. All right, so you pulled those down. Now we're gonna talk about actually hooking your computer up to a device today. But if you do have a Linux machine and you do want to use it to talk to your Android device, you do have to set up some device rules to make that work, and that's all documented here. So I just thought I would mention that since this is part of the setup that Google gives you at the Aosp site. All right, so you've got all the tools you need. Now we're actually going to get the source. So the first thing we do is we use curl to get repo. So we just download repo and pop it in our bin directory. Then we use repo to get everything else. So we make a working directory. We go into that working directory we call repo init with a URL that tells us where to get our manifest from, and optionally a branch tag to say the type, the version of Android we want to build. And you can find all those listed there. So I'm pulling down Android version 5.1.1, revision 3. That's going to chug for a few minutes and get repo is going to kind of set up its directory structure, and then you fire up repo sync, and then you go get dinner. And so yeah, you want to make sure you have a really good connection on this. At work, doing this fresh, yeah, an hour is about right. I have a terrible internet connection at home. I did that just the other night, and it took like 4 or 5 hours. So yes, several gigabytes of source code and other stuff comes down. And so obviously, I'm not going to show you that happening, but let's see here. Once you've done it, all right. Is that command line big enough for everyone to see? Okay. So I have my Aosp tree over here. So yeah, you can see that there's a lot of stuff there. So from the point of view of Java developers, the interesting stuff I think lives under frameworks and packages. So frameworks, as you might imagine, is the API operating system stuff, and packages. So a lot of the things that you think about making up an operating system really are just applications running there. So when your phone, when you pull up the dialer, that's an application. When you with the UI that manages switching between tasks, that's an application. They just happen to be very key to the performance of the operating system. So frameworks is kind of the behind-the-scenes API level stuff, and then you'll also find many applications here, some of which you might consider part of the operating system. So let's look here in packages. So examples of things, actual apps, input methods, those are your keyboards, screensavers, wallpapers, data providers, services. Let's go on further. Let's go into apps, see what's in there. So as I mentioned before, it's like, okay, I was like, well, you don't have all those Google apps. So like one of them is Google Calendar. Well, oh, there's a calendar right there. Well, it's a calendar app. It just isn't the one that you would download from the Play Store called Google Calendar. It's probably a perfectly fine local calendar, but it might not be, if you're going to sell it, what your users were expecting. So you can see there's a lot of stuff in there. Interesting things to look at. The launcher. you know, that's the thing that you look at that has all your app icons, that you tap an app icon and launches it. You know, that you might consider that part of the operating system, but here it is. It's just an application. So, but now you have the source for it. You can study it. You can figure out how the launcher works. Maybe write your own launcher. All right. Okay, so we've got Aosp. Now, here's where I start to talk about, so two things. So first of all, this is sort of an optional step. Because Aosp takes such a long time to build, there's lots of attempts at speeding it up. And one of the attempts that, one of the things the Android developers did was provide the option to make use of something called Ccache, which is, I confess I'm not 100% familiar myself with exactly how it works. So basically the idea is when your C compiler is running, I believe it's caching intermediate compilation results so that if you run a compilation, you don't necessarily need to build everything over from scratch. It seems like Make was supposed to do that, but this is perhaps doing it on a more finer grained level. So you can turn that on. It definitely helps. It doesn't help quite as much as you might expect because here's the downside. So much of Android is written in Java, and therefore speeding up your C compilations, which is also a chunk of it, isn't the whole picture. And the other thing that I personally run into a lot of times is if you've just got one version of Android there and you're iterating on it, it can be all well and good. But if you're jumping between configurations, like any cache, it can become stale and it can be a source of spurious results that cause your build to start breaking. So it's always, if you use this, it's always good to know how to clear it out when things mysteriously start going wrong. So the usual rule is you're building Android, the build starts breaking, so you make clean, you blow away all the makes cache, you keep building, it's still breaking, you clear C cache, hopefully you're back to scratch. You just have to wait a couple hours to rebuild everything. The other thing was, so I'm personally running, I'm up to date, I'm running Ubuntu 15.04 on my laptop. Mostly everything as described at the Aosp site worked. I ran into two things that I tripped over that I mentioned here. One is more of a annoyance. So in Ubuntu 15.04, they throw this Java tool options thing into the environment that is designed to basically cause, when you're running a Java application, to have the Ubuntu-style menus pop up on your menu bar instead of being in the window. Sure, that's nice, but then when you start compiling Android, suddenly you wind up seeing this jar file constantly being cited in all your compilations. Why is it there? Well, because the JDK is finding this environment flag and pulling this in. So you clear the environment flag, it doesn't do that. I haven't seen it cause any harm to the compilation. I just potentially might be slowing it down a little bit. The other thing was, this is I had mentioned big, now I'm going to mention brittle. I was compiling the Aosp and I started getting an error that was completely inexplicable. So the Aosp has this utility, so it's this big pile of Java code, and some of it is internal stuff for how the operating system works, and some of it is APIs that programmers can call. So how do we, when we have a public method, how do we determine, is this public because we want applications to use it, or is this public because we want this other service over there that's also part of the operating system to be able to see it? Java has no way to make that distinction. So in Android, there is a little comment tag that you put on a method called @hide that says when you build the operating system, anything that's marked @hide shouldn't be considered part of the SDK. And they have a tool that runs through and says, you know, here's all the methods that we said should be in the SDK. Here's all the methods that weren't hidden. Do they match? And that's the normal error. Well, so there's a tool that does that thing, and to do that thing, that tool has to parse files. And that tool happens to be written in C. And that tool happens to have a bug in it. And it happens to have a bug that doesn't break on glibc as it is in 12.14.4, but does break on 15.04. Fortunately, there's also a patch for it that you can apply. But this is the kind of thing. It's a big, complicated system that has grown up like Topsy, and it is subtle to it is liable to breaking in subtle ways. So a lot of times, you know, you just have to go to Stack Overflow and see who else is breaking it, and somebody clever will have figured it out. Okay, so you've got all this code on your device. You obviously can use it to build. You can use it to build a running version of Android. But I also mentioned that it's really useful for exploring. And if you decide that you want to make changes, well, the first thing you have to do is figure out where the changes can be made. So in Aosp, they've actually included some handy scripts that are designed to grep through the entire tree. So they have things like jgrep and cgrep. Jgrep greps through all Java files. Cgrep greps through all C files. So if you have an idea for the names of methods or particular strings that you see that you're searching for, that could be a place to start. However, I personally, when I'm doing this on a daily basis, I really love a tool called Silver Searcher. Silver Searcher is a generalized tool for the work of searching through large trees of text and finding stuff. And the reason I like it is it's really, really fast. So I actually recommend Silver Searcher. So, you know, you can use it to find files, you can use it to find strings within files, and AG being the symbol for silver. So I fired up, and even as fast as Silver Searcher is, if you fire it up at the top of the tree, it still takes a while, but it actually comes back pretty quickly. So I'm wondering, oh, where is the notification, or basically any class ending in notification.java living in my tree, and it is giving me results. So then I can go in and start looking at them. But here's the, you know, if you take away one slide, this is the one that I would recommend, and this is a wonderful Chrome extension called Android Sdk Search. And the reason I think it's wonderful is in some ways it lets you, if your interest in this is really in support of your Android application development, this lets you like skip around all the work of pulling down all that source, because I mean that source is available online as well. So if you install that Chrome extension, you type AD, then your Chrome search bar turns into a specific search across the Android developer documentation. So here I'm searching on notification again, and it's showing me all the places that appears in the Android developer documentation, both the class documentation and things like, oh, here's a tutorial on how to do this if I want to make a notification. But I'm going to go to the class documentation. So that's feature one. Definitely handy in and of itself. Fortunately, we kind of got a little bit of a slow collection here. But the other thing that it does that I think is even cooler is it actually makes some tweaks to the developer documentation itself. And since and I didn't even pull down the whole thing. Well, I'm going to try to let that run in the background while I continue on with the slides, and time is moving on here. All right, so if you decide that you do want to make changes and experiment with the Android source code, or simply you want to use an IDE as another tool for exploring this stuff. Here I've given you some instructions for setting up Android Studio to use Aosp. So for those who are not familiar, Android Studio is essentially IntelliJ. Is IntelliJ plus specific tools to Android development, and this is what Google now supplies as the default way of building Android applications. You download Android Studio, it's got the SDKs all baked in, it's got lots of cool tools in it, it's ready to go. But you can also use it for editing Aosp, although it's not specifically designed to do that. And I am quickly going to turn on my phone hotspot here, just in the hopes of maybe it's better connection. All right, so setting up Aosp. All right, so in Android Studio, so there's actually a little tool that comes with Aosp that unfortunately is perhaps only maintained in somebody's spare time because it doesn't quite get you all the way there, but it gets you most of the way there, called Idegen. So first of all, when you're dealing with Aosp, there is some generated code in there that is just huge. So the first, one of the hurdles I discovered was by default, Android Studio sets the maximum file size that it will try to parse to about 2.5 megs. That's not enough, so I had to bump it up to 4 megs. So that was one thing. Also, if you're running on Linux, Android Studio makes use of a Linux feature whereby it can set watches on directories so it can immediately respond when the file system changes underneath it. Aosp has a lot of files in it, so you have to bump up the number of those watches that an application can use. So there's a file to edit, and then there's a command to run to make that change take effect. So once you've done that, you're ready to fire up Aosp. All right, now you need a project. So what Idegen does, it's a, go see if my, oh, there I am. What was it show? So yes, so you actually have to build the thing first. Oh, I jumped ahead. So in your Aosp directory, you just go, there's a development directory, you go down, tools, Idegen. So as part of the building the thing slide, I think I kind of jumped over it. Yeah, in fact, I did jump over this slide. When you start working around in the Aosp directory, once you pull down all that source, there is a script file that you source that sets up a bunch of paths and environment variables for you. And one of the things that it does is it pulls in a bunch of commands and tools that are handy for navigating around the Aosp directories and source. And so you can see in this example I gave you of building the whole thing, I used the make command. But when you move down into submodules of all this stuff in Aosp, there's this handy command called mm. So I move into a particular module, I type mm, and it builds just what's in that module. So I build Idegen. Then croup basically jumps you back to the top of the Aosp tree, because you're usually like working multiple directories down, so I thought it'd be handy to have a shortcut. And then there's a script you can run, and all that script really does is run a jar file that this created. And I actually discovered that this script works fine as long as your output directory for Aosp, which by default is inside your tree, because in my case, I'm got the source on an external drive, but I'm directing the output to my SSD so that it runs a little bit faster. I moved my out directory, which Aosp totally allows you to do, but this script was not smart enough to figure that out. So I just looked at the script and ran the Java program directly. So what does that do? It creates a little IPR file. IPR file is a IntelliJ project file, so you can open that up. And at that point, you are actually good to go and open source files and move around and look at stuff as long as you're happy with seeing lots of red lines. So if you wanted those red lines to go away, you have to do a little bit more. And those things are, so, in fact, I'm actually gonna, actually, let me see if I now have the ability to, yes, okay. So, this is going back to the Android Sdk Search extension for Chrome that I was super excited about. The thing that I'm even more excited about, the fact that it lets me search the developer documentation directly from my Chrome address bar, is the fact that if I were to surf directly to this without using the extension, I would see notification and then some documentation. I would not see view source. This is super valuable, at least I think so, because I click on that and it jumps me right to ingit the source for that class that's part of Aosp. And so now, you know, a perfect example is like, you know, let's say I'm trying to put up a notification and I'm having some problems and I want to know, well, what happens when I actually submit a notification? Well, there's this notify method. Well, how does that notify method actually work? Well, I go to view source and I find it. I can search in my browser. And oh look, there's the notification method. And oh, what is it doing here? Well, it's getting some handle to a service, and then it's doing some things to make sure the notification is okay, and then ultimately it's handing that notification off to that service. So now, you know, if I have this Aosp stuff around, I can go search that Aosp source for this service, this iNotification Manager, and find out, well, what does it do? And I can follow things down. But even often just getting to this first level. And frankly, once you get an idea for how things are organized in the Android source, I don't even need to have the Aosp stuff on my disk if I'm working on an application, because I can do stuff like, oh, all right, let's just browse around the source and see what's there. So you can make those connections on your own. So this is the, in my life as an Android developer, this is the tool that I discovered that I daily feel is the most valuable. Yeah.
Can I make a quick suggestion?
Yeah.
Can you pull up AndroidXREF.com?
AndroidXREF, sure. Okay, AndroidXREF.com.
On the left side, click on one of the source branches.
Okay.
So this is using OpenGrok, which is a search engine that actually indexes source code, and it indexes a whole bunch of different languages and things like that. And it's conceptually the same sort of an idea, but this is like a full-blown search engine.
This is pretty cool. I was not aware of this. Thank you for the...
Yeah, the OpenGrok is the tool that it's based on, which is an open source tool. Hopefully that works.
Huzzah.
Oh, yeah. Check.
Nice.
That is super cool. All right, so thank you, Nimrod. Another tool. I will add this to the next version of my slides.
And if you want to set up internally, go to opengrok.com. That's where the tool is that they guide this up from.
All right, I can navigate it away from my slides.
Sorry.
That's okay. That's the thing about having slides in your browser, is that you forget that it's your browser and not an application. Okay, so I was talking about setting up Studio. Okay, so the main things here are, So because you're building the whole operating system, you're not building an app. When you come in here, this project SDK will be set to some version of the Android SDK. So it'll be like, you know, Android API 20. And if you don't change that, what happens is, remember I talked about there was this idea of hidden methods that the SDK is not supposed to know about? Well, if the SDK is the first thing in your search path, then when you reference classes that are part of the SDK, and you look at OS code that's using the hidden methods, they'll be like, no, these hidden methods don't exist. So you have to get that out of there. You have to say, no, I just want Java as my SDK, just pure Java. Then you go down into, and this is all in the project structure dialog, you go down into the modules, dependencies, and you'll discover that Idegen, in the process of groveling through the Aosp source, picked up a whole bunch of jar files and added them as dependencies. You don't need any of them. So you just go in there, you'll see this, except it'll have a whole bunch of jar files. Select them all, say remove. Finally, there's two things that in the Aosp sources that are not they're essentially generated classes that you need to know about. One reflects the Android resource system, whereby resources are things like bitmaps and XML files and layout files and all these things that go along with your code to make up your full application. And Android has a system whereby it parses these directories of resource files and then creates these Java classes that give you type-safe identifiers for all these resources. So those get generated, and so you have to pull in the directory where those wind up. And then Android also has this tool called Aidl, which is related to this thing I talked about at the very beginning called Binder. They're this inter-process communication system describing these inter-process APIs are done in an Android interface development language, which just kind of looks like a Java interface file, but it needs to be run through a generator to create a stub class that the compiler looks at to satisfy it. And so you need to include the framework directory, and you include that directory. In this one, you actually have to add the directory and then tell Aosp this is a source directory. When you add framework, Android Studio is actually pretty smart about scanning through it and figuring out where the source directories are. So that just kind of drops in. And once you have that, you pretty much have the whole thing. So let's see. So how much longer do we have here, Nimrod?
I got about 40 minutes.
40 minutes?
Yeah.
All right. It's not going to take that long. Yes, you have a question?
So at one point you mentioned that they define the public APIs and they compare it against, when they compared it, compares it against the public APIs as a pool in there somewhere, get the name. How are the public APIs defined?
Okay, so I will show you. So as an example here, so let's take a look. Yeah, it's okay. So let's look in Notification Manager. There's probably okay. Here's a perfect. Let me zoom in on that. Okay, so here's a perfect example right here. So the Notification Manager, when we looked in the documentation, you know, it had very few methods in the documentation. There was like notify to actually send the notification, and there was maybe one or two other things. If you actually look at the source, okay, it's got other stuff in here, like there's a method called from. And if we look at it, there's this comment right above it that says @hide.
Oh, yeah, no, I got that
Okay,
part.
so
So
maybe I
if
didn't
I were
understand
to
your question.
remove @hide from on here,
Yeah.
I would presumably get a compiler warning, a warning at some point saying,
Yes.
hey, that's not supposed to be
Yeah.
public. So it's comparing
Yeah, so
this
there
to
is a
another source.
file, and I the exact name escapes me. There's a file, it's called something like public APIs. Roman, do you happen to remember?
It's like public API 21 or something.
Yeah, so it's just it's a file that basically is like, here's all the methods that the world is supposed to know about.
Really, it's like a flat file.
Yeah.
On.
And so there is a tool, and I don't even know its name because it's just run by the build script, that, you know, when as part of the build, it runs this, it says, here is the list of all the public methods I've seen that weren't hidden, here's the list in the file, are they the same? If not, throw an error.
I half expected it to be Idegen or something like that.
Right, no, and then there's even also a tool where you can say, okay, whatever the set of public APIs you found, those should be the set of
Just
public
add it.
APIs, just add it.
I see.
And so if you are creating your own version of Android, you may well decide to do that. You may go, hey, I want to add new public APIs, here they are, build system, recognize that that is true. But the whole point of the tool is not to make it impossible to add new public APIs, but to prevent you from accidentally creating public APIs. Because here's the thing. And these are hidden from as far as the SDK is concerned, but they're still Java public methods. You can still call them. So if you are feeling like living dangerously and you're writing your application and in browsing the source you find this cool method that does exactly what you need, you can call that either by using reflection or by creating a fake version, you know, essentially a stubbed version of the class and including that and putting it in your path in front of the SDK jar. There's lots of ways to fool the Java compiler into accepting that yes, this is really a method, and then you can compile and, you know, if you run it on the right version of Android, it will absolutely work. You should probably surround that with a little bit of defensive code that says, if this blows up, what do I do? Because you know, there is no obligation in the next version of Android or the previous version of Android that this method exists because it was not made part of the
You
SDK.
probably failed certification as well.
Well, see, that's the thing. There really isn't, that isn't a thing. I mean, as an Android application developer, you write your application, you submit it. Unlike Apple, Google is not in the business of saying, we're not going to allow you to take risks. There are plenty of applications out there that use unpublished APIs, and Google doesn't care one way or the other. So you can do it, it's just you are now accepting the risk as a developer that, you know, users download your application, they click go, and your application blows up, and then you're the one with egg on your face. Other questions? All right. I'm actually gonna wrap this up here because we've been going for quite a while. So, just a few more little things. Just a few tools. So, all right. So, actually, since we have a few minutes, let me go back quickly and do a thing that I skipped over here. So, where was it? It was the actual build thing. So I can't show you an actual build because, as mentioned, that could easily take a couple hours, but I can show you sort of the process leading up to it. Here we go.
Hey, Wilhelm, you have at most 40 minutes. So.
Okay, I am not going beyond 40 minutes. In fact, I don't want to go too long. Okay, so you want to build Aosp. So you downloaded the code. You go into the directory where you downloaded the code. So I mentioned, okay, so here we are in my Aosp directory. So I mentioned that the first thing you need to do is is source this file to get some things set up. And I've actually, created my own script file to add a few more things, to set up Ccache, which I mentioned, to move my my output directory, and then for purposes of the latest version of Ubuntu to get rid of that Java tool options. So I'm going to get that guy first. Then I'm going to go into Aosp and start doing the Aosp thing. So let me, oops, that's not what I was going to do. I want to do that. Okay, so I'm going to source, build, and setup. All right, so as you can see, it's pulled in a whole bunch of stuff. You can see mentions of various devices. Looks interesting, mentions of emulators. Now, once it's set that up, there is this command that tells you something about what it just did. So we can see that, okay, it's defined a whole bunch of handy things, tools, utilities, and commands that you might use to get things done within the context of Aosp. So here's the grep tools that I talked about. Here's variants on this M command that is used to build specific modules. But the first thing I have to do is decide what configuration of Android am I building. Am I building it for a specific device? Do I want to build an emulator? What do I want to do? So there's this command with the name of lunch. I think it was called lunch because if you're about to build Android, you might probably planning to go to lunch as soon as you launch your build. And right up at the top here, so all these names like Shamu, Manta, Mako, Hammerhead, Fugu, these are references to Nexus devices. For those that are not familiar, Nexus devices are the Android devices that are sold directly by Google. You know of them as the Nexus 4, the Nexus 5, the Nexus 6. But in the grand tradition of code of developers everywhere, of course, the people inside the project have to give them unique and mysterious names. So, eventually you learn that, Mako is the Nexus 4 and Hammerhead is the Nexus 5. So if you want to actually build Aosp and put it on a device, you can do that, but out of the box, only on a Nexus device. So other Android devices have unique hardware drivers and all sorts of stuff that they need, and that kind of configuration stuff is not made generally available by the vendors of those devices. But there is a way, which I will talk about at the end. So for the purposes of this, I decided I want to build an emulator. So these guys right up here are the emulator. You might be wondering, what are these things down here that say emulator? The mini emulator is basically Android without its user space. Might be useful if you are working on a device driver and want a little tiny thing that starts up really quick. I've never played with them, I just learned what they are. So these top guys here are the emulators, and since I'm going to run this thing on an x86 machine, and since it turns out that that Android now knows how to take advantage of that kind of virtualization, I'm going to decide to build the Aosp X86. So I picked 5. And it thinks for a moment, and it sets up a bunch of stuff, and now I'm ready to build. So at this point, if I was really brave, I could type make, and this little flag down here, if this is basically telling make how many threads to use, and all the research I've done says somewhere between the number of hardware threads your machine has to twice that number. So my machine happens to have, I think it's 4 cores, each with 2 threads, so somewhere between 8 and 16 probably gives me the best result. But I'm not going to do that because I did that a while over. Once I have done that and I had built this thing, I can now type emulator, and boom, in a few moments, there is Android running in a little window. So this was sort of the goal of the talk here, is that okay, you can download Aosp, you can build this emulator, you can play around with the emulator, but more importantly, if you wanted to, you could now go in and start changing things in Aosp, and you could recompile this emulator, and you could see how your changes work out, all without having to worry about how to get it on a device. Because I hate to say this, so if you're dealing with the Nexus devices, and you go to the Android open source project, there are some fairly clear directions for how to take your Nexus device and unlock the bootloader, which basically means allowing it to install operating systems that haven't been signed by the manufacturer, which on Nexus devices is very easy to do, and then taking something that you built and flashing it on that device. It's actually not that hard, but the general topic of running custom Android on devices could easily consume another presentation like this. So I wanted to focus on the emulator, a great way to get started because it will run on any, you can build it and run it on any laptop and play around with it and see what Android looks like running with your experimental changes in it. Let me hop back to the end then. So I mentioned that I didn't want to, I really feel like I had the opportunity to cover the architecture of Android in much depth, but I just want to give you just a few quick hints that might help you out if you do decide to dig into this. So I've mentioned several times that the structure of Android really is a whole bunch of cooperating services. So that's what this diagram tries to bring out really here. We have our Linux kernel. On top of that, there's been a hardware abstraction layer that's been defined so that all this other stuff can be common across all Android devices. And only the HAL has to have code that knows how to talk to specific device drivers down in the Linux kernel. What you'll find as you look around is there are these services. These services do things like there is the window manager. What does that do? Well, it manages the where things get drawn on the screen. Or an application comes up and says, okay, you have this space to draw into. Oh, another application wants to come to the front. Okay, we'll put its UI up there and take that one away. You have the activity manager. Like this, Android applications are built out of these components called activities. If you're a web designer, you can kind of think like each activity is a page. If you're if you're a developer of another kind, you can think of each activity as a screen. So within an application, the relationships between the activities need to be managed. There's a service that does that. There's the package manager service. What does it do? Well, you want to install new apps on your device. You want to uninstall apps from your device. Package manager is the thing that knows how to do that. So they all talk to each other, and they all talk through this mechanism called binder. And as you look around, you'll basically see kind of a rule that stuff that deals with, deals sort of directly with the hardware and potentially in a very performance-intensive way, those are the things that you'll find that get written in C or C++. So things like, there's Surface Flinger, which is the service that is the sort of fundamental thing that manages the surfaces that get drawn to. There's Audio Flinger that manages your audio streams. There's the camera service. Those kind of things, media player, those kind of things tend to be native binaries. But a lot of the other stuff, the sort of more bookkeeping part of it, is written in Java. So as Java developers, that's really where you can get your hooks in. And with that, I'm going to mention one other thing. So I mentioned earlier when talking about devices that Aosp out of the box only works with Nexus devices. But there's this big community out there of folks who are really into this stuff and have spent years and years and years hacking on Aosp, and communities of interest have grown up around this, and they've pooled their knowledge, and the largest and most active of these communities is something called Sienagen Mod. And what the Sienagen Mod community does is they take the Aosp sources, they put it in their own tree, and then they hack on it. And one of the things that they do is they add support for lots of other devices. And this is quite an adventure because it involves collecting binary device drivers, finding, for example, so the GPL says you have to release your source. So by and large, for every Android device that's released, whatever the manufacturer had to do to the kernel to make it run, they have to put a tar file somewhere. But they don't have to make it particularly usable. So the CM folks that are working on a particular device may go find that. They may incorporate it into a standard Linux kernel. They may get a kernel running on the device. They extract the binary device drivers from the manufacturer's version of the operating system. They figure out how to plug those into Aosp. There's lots of work that goes beyond this, but the key thing is for you is that if you are using a popular device, it's very likely CM has done the work for you. So the process of getting CM, if you want to work on it as a developer, is very much like the process of getting Aosp. You use repo, you just get a different manifest from a different place, from the CM repository, you pull it down, you say repo sync, and all this stuff comes down. If you just want to run CM on your device, then you can get precompiled versions and figure out the way on your particular device that you need to do to actually get that flashed onto there, which varies greatly. So support for devices that have been end of life by manufacturers, but also the CM folks are not satisfied with just saying, hey, we're going to make Aosp run on it. Lots of them are clever folks and they have ideas for how to make Android better. They have features that they think that would make Android better, specifically for them or for the world at large. So so CM has extended Aosp with interesting things like Privacy Guard, which is kind of similar to the runtime permissions things that Android has only just announced in the M version that's coming out. Profiles, which is a way of having your device quickly change between configurations when it gets events like, oh, I'm home, I'm connected to my home router, so I should turn off my lock screen or something like that. Quick tiles, being able to customize the quick commands you have when you pull down. There's lots of features that it adds. And it is the largest community that is working on open source Android, although there are others. And I call out, there's 2 of them, but there are many more. AOKP, the Android Open Tank project, OmniROM, it's kind of like the world of JavaScript frameworks. There's an Android ROM that pops up every day. Earlier on I mentioned I work for Sienagen Inc. What is Sienagen Inc? Sienagen Inc. is a for-profit company that was founded by the same guy that founded Cyanogen Mod, Steve Kondik. And I think the fundamental rationale behind why Sienagen Inc. exists is that Cyanogen Mod devs needed day jobs so that they could do what they love all day instead of just doing it in the evening. But we are a company and we have some ideas about how Android could be better. So we have these principles which are kind of derived from the philosophy of CyanogenMod itself, which is that your device should be customizable, your device should be performant, and your device should be secure. So Cyanogen is making a version of Android that is extended in ways that we think are interesting and that adhere to these principles. And we are delivering that as Cyanogen OS, which is just a flavor of CyanogenMod, but here's the important thing, we do the work to pass the Google certification so we can include the Google apps, which means that you can buy phones today, not a whole lot right now, but every month there's going to be more of them, that has Cyanogen on it as the first OS. You don't have to figure out obscure command lines to flash CM on your device. And has all the services that you expect from a modern mobile operating system. And if you're interested, we'd love to hire you.
And you're in Belltown.
And we are in Belltown, yes. We are first in Cedar, right across the street from the Labor Temple. And so if you are excited by this and you want to learn more, obviously the place to start is the Aosp Docs. In the slides, I pulled out the URLs to the specific steps of setting up your machine, downloading the source, building the source, but there's a lot more stuff there. If you're going to do work on Android, obviously you need the developer docs, so you can learn about all the APIs you can call, and then specifically on the topic of understanding the architecture of Android as an operating system and how to change it the way you want. I was introduced to this book by Andy Mast, one of my coworkers, Embedded Android. It is a little bit out of date because Android moves fast. It was originally published for the 2.3 version of Android. It was updated for the 4.2 version of Android. But I would say 80–90% of what is in there is still good, valid information, especially in terms of understanding the big picture of how all the pieces fit together. So if you are interested in going further with this, I highly recommend getting a copy of Embedded Android and reading it thoroughly, because it will orient you in ways that I could not in an hour and 30 minutes.
It'll save you a lot of time.
Yes. So that is what I have to offer. I guess I have maybe 10 more minutes, so questions if there are.
What was the name of the extension?
The Android, it was, I always forget, it's in my browser, it does the thing. I believe it's just called the Android Sdk Search. Let me find it. Android Sdk Search. Brilliant.
Go ahead.
Oh, there we go. Yes, there it is, Android SDK Search.
Thank you.
Any other questions? All right, well, thank you for listening to me, and
Jason, did you have a question?
oh,
Yeah, something like that. Any idea what the original Linux variant that Android started from? Gen 2 or Gen 8?
none whatsoever. I mean, it's very clear that they took the Linux kernel and a minimal Linux user space and stripped everything out, and, you know, because again, the development of the Linux standard base and the Linux ways of doing things, there's a lot of history in there, you know, a lot of stuff that makes sense for, you know, desktop machines, you know, in some cases not even laptops. So to make a truly mobile operating system, they were prepared to, you know, strip things down to their core and rebuild that from scratch according to the principles they had established for what makes a good mobile operating system.
Cool. All right, anything else? All right, thank you all. FYI, for people who may have come late or may not know about this, we're doing a raffle for OSCON. If you don't have one of these red tickets, please come and grab one. And while we're waiting, in case anybody wants to do that, I actually forgot to introduce Fran, who's here from Ireland, actually. And he wanted to speak for a few minutes about some of the community stuff that they're doing, I think at Intuition, if I'm not mistaken.
That's right, yeah, thank you. Yeah, so really quickly, my name is Fran McKegney, I'm head of technology with a company called Intuition Publishing. We've just released a new product called the Intuition Tech Channels, which is a set of curated content channels for software professionals. We worked with the O'Reilly Publishing Company, I saw the book mentioned there, and about 100 other publishing companies, book companies, digital media companies, and working with subject matter experts, our internal curation teams kind of trawl through this treasure trove of resources and come up with a set of deep content channels on different subjects. We've launched with 6 channels. Ones that may be of interest to this group are, we have a Java channel, we have a mobile application development channel, which includes Android development. And we wanted to offer everybody here and the Java user group here in Seattle full access to the product. We will post a code and a URL tomorrow. I'm not sure whether
I'll get it out.
You'll get it out. And we'd love to get you, you know, have a look at it. We hope you like it. We hope you find it useful. We would love to get your feedback. We have tremendous ability to continue to update these channels on a really regular basis with the latest, greatest resources that we can find. And we're really trying to support your work. your development work that you're doing. And so let us know what you think, the good, the bad, the ugly, and as I say, we will use that feedback to shape the future of the product. So it's called Intuition Tech Channels, and you can look out for the posting tomorrow on that. Okay, thank you.
All right, thank you, Fran. All right, so anybody else want one of the red tickets? Okay, Wilhelm, and do the honors.
And the lucky number is 792315. 315? Anyone?
I mean, we may need to go more than once. Some
Okay.
people left, and I think I had more tickets out
Must
there.
be present to win.
All right. How about 792334?
334. I think they're all 7. Almost last
Yeah.
year.
All right. Drum roll, please. 306.
306. Nobody?
Oh.
373. Keep
A
going.
lot of empty tickets
yeah.
out there.
Should have taken 2.
Oh, okay, well.
All right, did you just select 376? 376.
Hang on, let me grab, was it 324? Let me grab the other stuff, otherwise you won't, and what
Oh,
was
really?
yours?
Oh.
324, and what's yours? 325, all right, hang on a second.
All right.
You just say 324.
Make sure you have 326 also, I grab mine late.
You know which one's out here.
Oh, yeah. All right.
Actually, I think those are already in there.
Okay, well, let's try 307. Going once, going twice.
Keep rolling.
All right, 326.
Yo!
Yo!
Give it away, or is
Years of service.
Yes.
Raymond wins the pass to Aosp.
Cool, Jason, just email me afterwards.
You got it.
All right, cool, thanks for coming, folks, and we'll meet next month, 3rd Tuesday. If you're gonna go for beers, please stick around, and have a good night.
Yeah.